All right, we're still rolling through our study guide here, a long way in. Actually, these are more solving, but I wanted to do a fresh video because these are the ones with fractions, and this is kind of an important concept that we definitely want to know how to do. So I'm gonna zoom in, make it a little bit easier to see. Those fractions are pretty small. So, all right, so for part D, I think this is still question 24, 23, 24. We want to eliminate our fractions first, right? We really don't want to deal with fractions, subtracting all the steps with fractions. So if I can get rid of them first, that's a good thing. So kind of ignore that D out there in front. And we're going to get rid of them by multiplying by the lowest common denominator. So 4, 3, and 4, they both go into 12. So I'm going to multiply all the way across by 12. Right? And I'm going to end up, when I do that, with 12 over 4x plus 12 over 3x plus 12 times 7 is 84. Oops, sorry. That's an equal sign. Equals 84 over 4. So I just multiply every single thing by 12, and if I pick the right thing, then all these fractions will go away. 12 divided by 4 is 3. 12 divided by 3 is 4. 84 divided by 4, punch that in the calculator if I need to, it's 21. So now I combine my like terms. 7x is 21, and the x equals 3. All right, so we're going to do the same thing over here. We got fractions 2, 3, and 6. Actually, they all go into 6. So I'm going to multiply my 6 all the way across. And I'm going to get 6x over 2 plus 6x over 6 equals 6 over 3. And 6 over 2 is 3x. 6 over 6 is 1x. 6 over 3 is 2. So 4x equals 2. And then this, on our last chapter exam, we had a problem just like this. We got to this point, and I had a lot of people tell me x equals 2, right? So we want to make sure, I'm going to take a second here. If I divide away this 4, right, to get the x by itself, that's what I'm doing. Divide away the 4. I have to do the same thing on this side. So I end up with x equals 2 divided by 4, which is 1/2. Right, so make sure we know our fraction rules there. And then at the very end of the row here, another one. So 3, 4, remember this 3 is not a fraction, so I'm going to put it over 1. And again, common denominator here would be 12. So I'm going to multiply 12 all the way through. 24x over 3 plus 12x over 4 equals 36 over 1. And if I divide all these numbers out, they'll go away. 8x plus 3x equals 36. And yep, all right, just double checking because 11x equals 36, and then I divide away the 11. A lot of times we don't get fractions that look like that in our answers in Math 1, but it's totally possible, and I think that's correct there. So sometimes when I get those, I double check my work because, you know, it's not super common that we end up with ugly fractions like that. All right, so those are done. And then we're going to look at solving these right here. So this was, again, a bit of a problem on the last test. I don't know that we spent enough time on it. And these are actually harder than what we did on the last one, so we need to kind of, slightly harder, not much, kind of examine these a little bit here, right? So if I look at like part G right here, it's telling me that these two sides are equal, right? The left and the right side are equal. Well, if the bases are equal, the 7s are the same, then that means that the exponents have to also be the same. So I know that 2 plus x has to equal 3x minus 4. Right? And so once I get to that point, I mean, it's really just solving like I always have. So I'm going to go ahead and Subtract x from both sides. Subtract 4, go away, same thing here. So 2x equals negative 2, and so my x is negative 1. Same exact thing over here. I have the same base, 3 and 3. That means that if the sides of that equation are equal, then these exponents have to also be equal. So 2x equals x minus 4. Subtract the x from that side. X equals negative 4. Done. Right, these are not nearly as complicated as some people were fearing. Okay, this last one here, I, is a little bit more complicated, right? Because I need the same base, but I don't have the same base over on this left side, so I have to make it that same way. So I know I'm not going to touch that side, but over here, 36 is 6 squared to the x power. Right. So if I think about my exponent rules, if I have a power to a power, then I multiply them. So this would be 6 to the 2x equals 6 to the x minus 3. So I didn't change anything on the right side that whole time. And now the bases are the same, so I can kind of forget about those and just focus on this part up here. So 2x equals x minus 3. Subtract x, and x equals negative 3. So that's how those work right there, and that's all of those, right? Yep. All right, I'm going to do one more in this video and then focus on the exponent rules. So 25, for the following graphs, identify the domain and range. Right, so remembering what this means, right? So domain is the x and range is the y. So what are the x's on the graph, right? So if I look at this first one, remember we looked at it like a picture. It starts at negative 4 and it finishes at 4. So the domain, the x is between negative 4 and positive 4. And my range, I should have range in different colors. The range, the bottom is negative 1 and the high point is at 3. So my y is between negative 1 and 3. Remember, we kind of made it like a border around the whole thing like this. Right, same thing here. So if I look at, see the low point and the high point, and the most left and the most right, I kind of frame in my graph, and I can see, whoops, this is supposed to be green over here. And so my domain, my x, right, it was between negative 3 and positive 5. And my y is between negative 2 and it goes up to positive 4. So people get scared by this domain and range stuff, but it's pretty straightforward. All right, actually I'm going to do one more in this video. Simplify each expression into an equivalent simpler form with no negative exponents or parentheses. So I'm going to zoom in a little bit so we can see a little better. And we're going to just focus on this part by part. So first we're going to look at the numbers. 15 over 3. This is a fraction, right? So I had some people this last exam even still wanting to apply the exponent rules to the coefficient, to the numbers, right? If I look at the x's, I have, when I divide, the exponents subtract, right? But I don't subtract the numbers. I'm not going to end up with 12. I'm still going to divide the numbers normally. So 15 over 3 is 5. Right? Then I'm going to look at the next part. X squared on top, x to the 4th on the bottom. That's going to leave me 2 x's on the bottom. And then I have y to the 5th on the top and the bottom. Those things are going to reduce down to 1, right? The same thing on the top and the bottom is a 1. So this is my final answer right here. And if I think about what the rules look like, it would be 5. And then the x's, I have 2 on top and 4 on the bottom. So, no, you know what? That's going to be too confusing. There's going to be a lot of double negatives and stuff. Let's just stick with this way. All right, 26 B, so here I'm multiplying everything together, so this is really easy. So the 6 and the 3 to go together to give me an 18. And then I have the A to the second and the A go together to give me 3 A's. And then I have 3 B's and 5 B's. Those go together to give me 8 B's. Final answer. And last one here. For some reason, this dot right here threw everybody off on the last test. It's just multiplication like everything else. So first we got to deal with this part. So I have a power to a power. So I have, that's going to go with both. So I'm going to have 2 squared x to the 8th times x to the 3rd. All right, still I'm putting that dot there so you can see what's happened. So 2 squared is 4. X to the 8th times x to the 3rd. I just add them together. Final answer. All right, so that takes us through 26. We've got just a couple more to go, and we'll pick it up here with number 27 in the next video.